Hello everyone, it's Benny, and welcome back to the 3D game programming tutorial series. Today, we're going to begin our journey into implementing the core game mechanics. And the way we're going to begin that journey is by breaking in the ECS. The ECS is going to be central to pretty much everything in our game from here on out. So, what we're going to do is we're not going to go too deep into any particular one of those core mechanics. We're eventually going to move into the render pipeline first, but that's not in this video. In this video, we're just going to take our existing input code and we're going to move that into the entity component system, break it in, see how it works, see if we can get it running, and as you'll see, by having this new entity component system, it's going to start making our whole code way simpler, way cleaner, way easier. And that'll be something to look for as we go through this. But that's enough rambling. Let's dive in. Let's get to it. So, to get things going, we're going to break in the ECS. We're going to go to main.cpp, and we're firstly going to include the ECS, which apparently I already did at some point. I forgot I did that, but hey, we have the ECS. That's the important thing. And we're going to create our very first component, the transform component. So I'm going to create a struct, call it transform component, and like for our convention, this is going to inherit from the public ECS component of type transform component. And what's going to have? Well, of course, it's going to have some transform, and that's it. Boom. We created a component. Simple as that. That's all that's needed. We're done. Isn't that nice? The ECS system might have been a lot to build, but now that we have it, look how easy that is. Boom, transform component's done. So now I'm going to scroll down, and let's use it. Right here, I'm going to create my ECS, call it ECS, and let's see what we're going to do. Let's just break it down to sections. We're going to create components, we're going to create the entity, and we're going to create the systems. There. So what's our component? We're going to have a transform component. I'll call it transform component. There you go. And what we're going to do is we're going to take, oh dear, the transform in this component, and we're just going to say set translation to vector 3f 0, 0, 20. We're setting it to 20 because, if I'm not mistaken, yeah, I believe that's currently the z value we have for the monkey heads. Just setting it to the same thing we already have. And there you go, that's the component set up. And now we can do ECS.makeEntity. It's going to take in the transform component. And we're done. We created the entity. Very straightforward system. And at this point, we would add in our systems so we can actually do something with these entities. But as it is now, we don't have any systems yet. And right now, I just want to break things in really quickly. So I'm going to cheat. I'm going to create an entity handle. I'll just call it entity. And what I'm going to do is, yeah, right here, where I'm setting my position based on movement, I'm going to change that because I'm just bad and evil like that. What I'm going to do is I'm going to get a transform reference. I'll call it working transform. And this is going to be ECS. We're going to use our getComponent method. We're going to get the transform component from our entity. And then we're going to say get translation. Actually, no, I can just say that dot transform because that should already be, actually this should be a pointer, so I need arrow notation transform. This should be getting me a reference to the transform. There you go, that's good. So now we have the transform reference, and now we can do whatever we want with it. We can change this to working transform dot set all this to working transform dot matrix. That's all good. In fact, I think that now I can actually go through and find our regular transform. Oh, regular transform. There you are. And I think I can just get rid of that. we shouldn't need it anymore. We're not doing anything with it. In fact, well, I'm doing something here, so I'll keep it for now. But yeah, this should be the basic setup for a very hacked up ECS system, because we're not actually doing any systems yet. Let's build and run. So I'm going to make and run. Hey, look at that. We've built, and we have exactly what we had before. Which doesn't really mean much, but now we're doing it with the entity component system, which is awesome. That means, at least in its most basic sense, it's doing what we expect. But it's not really doing anything useful. So let's fix that. Let's try and move our existing, input code into the ECS. So I'm going to create a struct. I'll call it movement control component. Sure. It's also going to be a ECS component. Of course, that's the whole point of movement control component. And what we're going to do is we're going to have a few things. We're going to have an input pointer for the input we want. I'm pretty sure I called that just straight up input. Did I not? No, I called them input controls. Okay. So input control pointer. This will be whatever input is controlling the movement. We also want a vector 3F for the movement. Yeah, sure. That's a good enough name. So that'll be the actual movement we're supposed to perform when the input is activated. And that's pretty much what we need for the basics. Now you might complain, hey, wait a minute, Benny. Right now this is only controlling a single input to a single movement. We're moving in several different directions. That's a valid complaint. And we'll address that in a moment. Right now, we're just going to go with the bare bones basics. So, and actually, I'm going to start off this initialize to null pointer, just because it's a reasonable thing for it to be defaulting to. So, with that, we can do exactly what we did with transform. We could have movement control, I'll call it movement control, sure. And what I'm going to do is, first off, I'll set the input equal to our horizontal input control, and our movement control dot movement. That'll be a vector 3F of course we want the horizontal axis, so 1.0 time, and so 1 on the horizontal axis, 0 on all the other axes, because we want to be moving horizontally. But you notice here we're multiplying by 10 because that's sort of our implicit speed. So we're actually going to want to increase this to 10. In fact, what I could do is I could say this, just multiply it by 10. Alternatively, rather than specifying it directly, that might be a little nice if we want to, say, make this direction some odd diagonal angle. This keeps the speed nicely separated. So I'll do it like that. Doesn't particularly matter. Only thing now is we want to add the movement component to our entity. And we could do a similar hack thing here just to show it's working, but I think you get the idea that the ECS system is at least keeping track of components properly. So let's skip the intermediate testing phase and let's just go straight into building the system for movement. So we're going back to the top and we're going to create a class. I'll call it movement control system. Sure. It's a descriptive enough name. And it's going to inherit from the base ECS system. And at this point you might wonder, hey Benny, why are you doing all this class logic in main.cpp? Wouldn't it make more sense for all these to be in their own separate files and, keep it reasonably organized? And you're absolutely correct. It would make a lot more sense for all of this to be organized into separate classes. However, for the next few videos, I'm going to be doing everything in main.cpp because as we do this, it will show that just by using ECS, there's a sort of natural, elegant design and organization system for everything that just sort of emerges out of using it. And I want you to see how it's sort of a natural thing. I'm not forcing anything, because it's just kind of cool how that works out like that. But anyways, so yeah, we're going to create the constructor, base ECS system. Oh, and of course, after we've seen the organization, then of course, yeah, we are going to refactor it into a decently organized thing, because this is not the best way to set everything up. But yeah. So the big thing we want is we want to add components to our base ECS system, specifically the types. So if I go to the ECS system, we have two key methods. We have the update components method and the add component type. In our constructor, we're going to want to add the component type. What do we need to do movement controls? Well, we need the transform component because that's what we're moving with the movement controls. And we also want to add the movement control itself because, of course, we need that. We need to know about the movement control to know, well, how to do the transform. And these are the entities we care about. If something has a movement control and a transform component, then this system cares about it and needs to do something. What does it need to do? That's what we're going to decide in our virtual void update components method. So the first thing we're going to do here, I'll go ahead and bring this back to full screen, is we're going to create variables for our transform component. Transform, and actually what did I just do? Okay, there we go. I'll take it by reference for now. Create transform reference. And what this is we go in our components, the first index should be the transform component, because that's what we set up first when we added our component type. We added the transform component first, so therefore our ECS designed to set the index 0 of components to transform. The first index because first added. Makes sense, right? And we're going to cast this to a transform component pointer. And we could go through the trouble of dereferencing it, but I'm just going to change it to transform. It's never going to be null because our ECS system guarantees that. So that's good. We don't have to worry about null pointers. Same sort of concept for movement controls, except movement control is going to be at index 1 because, well, second type added will be at the second index. And the movement control, yeah, that's good enough name. So we have the transform, we have the movement control, so what? What we want to do, right? So what we want to do is we want to do movement control, we'll look at the input, and we want to use our getAmount method. Because if you remember from way back several videos ago, we have this getAmount method that'll tell us how much the input is activated. Basically, we're going to be doing what we're already doing down here. So in fact, I guess I'll just go ahead and copy and paste this. Sort of. I'm only going to copy this part because this is what we're going to be doing, just a little bit more directly. So yeah. So, in fact, I'll just say float move amount equals this. And actually, I can do one better than this. Because we want the amount, we want to multiply this by the movement control arrow movement. Because that tells us, hey, how much are we actually moving in this particular direction? And we also want to multiply this lastly by delta. Because that'll tell us, that's basically the equivalent of frame time. It tells us how much we're moving given the amount of frame time we're updating, the amount of physical time we're updating by. And this isn't actually a float, so I'm going to change that. But yeah, you get the idea. This is how we're doing it. We take the amount of input controls down, we multiply that by the amount we move, and multiply that by the amount of time we're moving over. And that should give us the total amount we need to actually move based on the controls, movement, and delta. But yeah, so all we're going to do here is we're going to take our transform arrow transform, we're going to get translation, and we're going to add this. And we're going to say this right here is our new position. It's a little bit of a mouthful, but that's fine. It gets the job done. Spoiler alert, there will be a better way to do this coming up in a few videos. But yeah, we're going to do this. We're going to once again say transform, transform, and this time we're going to set translation to our new position. And that's that. We have a movement control system, and I also need to name the constructor correctly, or this is not going to work out very well. So hang on a second. There we go. And great. So at this point, what we can do, scroll down to our ECS, we can have a movement control system movement control system. Sure. And we can say ECS add system movement control system. All good. Except, wait a minute, because I forgot we've already done the refactoring to move add system into its own class. So, whoops. That's fine. This is good. This will be good for the long run. So, ECS system list. I'll just call it main systems. These will be the main things as things we expect to be updated pretty much all the time. So main systems, we're going to add the movement control system. And there, now we have our systems. And once we have that, it's pretty okay. We should be able to get rid of the set translation part. The rotation, we're still not doing, but that's okay. In fact, I'm probably going to end up just getting rid of this because you get the idea. It's just there for show, really. And yeah, you're just going to say ECS.update systems. We're going to pass in frame. Yeah, our main system list and the frame time, though I forgot precisely which order I did. So let's go to ECS and just check that out really quick. ECS update systems, systems list, then delta. Okay, so main list, then frame time. Perfect. Now we should, in theory, if I haven't forgotten anything, have our ECS system handling input. So let's make and run. Oh, right. I need to... There we go. But of course, I'm sure I've forgotten something. Yes, I did. Our movement system is entity. Okay. First of all, right here, this is by pointer, because input itself is a pointer, so that's kind of important. And ECS make entity movement, we did not call it movement, we called it movement control. So with that, we will probably have an issue. Okay. No match for operator multiply between float and vector 3. That seems wrong. One moment. Okay, apparently when I did my vector library, I forgot to define the second float vector multiplication, the one where it's on the other side. So we need to do the variables in this order. Okay, I'll probably go back and fix that at some point, but you know, for now it's not a terrible, huge deal, just order of operations and whatnot. And here our thing is, and look at this, we can move it horizontally. I can push left to go left. That's right. You get the idea. I can still push left to go left and right to go right, and everything is working out splendidly. It's actually gone back a little bit further than usual because I think now we're double translating the Z component, but that's okay. That is entirely within the realm of reason. That's acceptable. So, great. Now we have basic movement controls working. So, at this point, we can go ahead, round it out, and do the Y movement. And you might think, okay, that's completely reasonable. All I need for the Y component is to take another movement control component with the vertical and its own movement. Everything should be good. Except that's not okay, because we have a rule in our ECS, only one component of a particular type is allowed on the same entity. So we can't have two movement control components because those would be two components of the same type. We could modify our entity component system to allow that, but actually I did that in a test repository, and that actually gets really, really messy really, really quickly, and it's not worth it. Especially considering there's a very easy way to do what we want without having multiple components. And that is, just turn it to an array. An array of vector 3f movement, boom, done. An array of input control pointers, boom, done. All good. And we're pretty much okay. So now movement control components has an array of movements, an array of inputs, for, yeah, what it wants. Now, something we could do, since technically there's a little bit of a thing here, what we could do just to make it a little bit nicer for, well, maybe not for coding purposes, but for the purposes of enforcing validity of the component, we can make this a pair of vector 3f and input control pointers. And this, yeah, I'll just call it movement controls. The syntax is a little bit bulkier because now we have the pair involved here, but this way we can't have, say, a whole bunch of movements added and we won't have the same amount of matching input controls and then the whole thing crashes down in a terrible exception. Or really segfault, really. But yeah, this will be a little bit nicer. So what we're going to do here, something very similar, except now we're going to have a for loop. I equals 0, I is less than movement controls dot size, I plus plus. Yeah, we're just going to iterate through the list of movement controls. I'll go ahead and go full screen to make this a little bit easier for you guys. And the difference here is now, instead of accessing movement control arrow movement like this, we're going to say movement control arrow movement controls sub I. And here, that'll give us a pair, and we want the first, because that will be, yeah, that will be the movement, that'll be the vector 3f. So in fact, just to make this a little bit clearer, I'll just say vector 3f movement equals this. That'll get rid of a little bit of the syntactical nonsense. And we also want the input control pointer input, which will be same sort of thing, except it'll be the second. And yeah, so now we'll add movement times input get amount times delta. And I'll just go ahead and add a space here just to make it a little bit, hopefully, easier to read. And there we go. That should be pretty much what we need. So now, rather than doing our movement control like we have, we'll say movement control dot movement controls. We're going to push back, and because some people have been bringing this up in the comments, I'll go ahead and just use std make pair. Doesn't really make a difference beyond syntax, but you know, there it is. So we'll add the mount to move and the horizontal. There you go. And we can do the same sort of thing for however many controls we want. So if I want to add a vertical control, I'll change this to vertical and change this to the address of vertical. And this should give us the same thing if I did everything wrong. But of course I didn't, because that would be too simple. So my error here this time is I forgot movement control arrow movement controls. Now everything should be okay. Hey, look! We have our movement controls. They are working just like before, minus the fact that our thing is now like way off in the distance. So actually, while we're at it, let's fix that. What we used to be doing is this transform matrix space array just for the demo. We don't need that. So really, all we want here is we want to change this. In fact, we don't need this transform matrix array thing we have. We just need to update the buffer with perspective multiplied by transform, working transform array to matrix. This should get us everything. While I'm at it, I'm going to go ahead and just get rid of this working transform thing, because we don't need that. So let's build one more time. Now it should be in the correct position. And it crashes. Why? Okay, and it's pretty straightforward, actually. What we need here is we actually need an address of a matrix array. In this case, we only have one matrix, so it's okay. So I'm just going to create a single matrix. I'll call it transform matrix, and that is going to be equal to this. And we're going to pass in the address of this transform matrix, and rather than dealing with the transform matrix array size, we're just going to say straight up size of matrix. And that should be good. So we should be able to build and run now. Excellent. And look at that. We have our input handled by the entity component system. And we can move our monkey head around all we like using that. But with that, we really don't need our transform matrix array nonsense anymore, so we can just go ahead and delete all of this. Delete the rand scales, all this. Yeah, pretty much between device params and colors, we should be able to get rid of. We should also be able to get rid of this amount variable. So that's a whole bunch of things just completely gone simply by using this, yeah, as it is. And if I build and run now, we no longer have num instances, which is okay because I know there's only a single instance. So, and we can get rid of amount because we're not using it anymore. Which reduces what we need to do every call even further. And there we go. We are pretty much done. So, with that, that will be everything for this particular video. We now have our ECS system broken in. We're doing all the crazy input stuff we used to be doing, except now it's done with the ECS. And if you look, it's a lot cleaner. Pretty much all the logic is encapsulated within these classes, and that is very interesting. I did not know you could do that with them. How did I do that even? That's really cool. But nevertheless, that leaves us with our main query. We now know the ECS system works. How can we use it to start implementing our core mechanics? How can we build a render pipeline using our entity component system? Can we perhaps even get that crazy Vim effect again? Find out next time. I hope you enjoyed, I hope you learned, and I will see you all in the next video. As always, if you want to talk more with me or other like-minded people, please join the Benny Discord. It is a fantastic time, and everyone is welcome. If you want to find out right now, or just want to feel good for supporting these videos, then consider becoming a patron to get early access to videos. And a very special thank you to all my patrons, and especially those listed in the video description, for just being generally the cool kids. Thank you all for making these videos possible. So that is all for this video. Thank you, and I will see all of you in the next video.